The ForFreight project aims to make freight transport across Europe more efficient, flexible, and sustainable. By advancing multimodal logistics and promoting seamless cooperation between ports, terminals, and hinterland networks, ForFreight reduces transport costs and environmental impact and improves operational capacity and service visibility. At the core of this initiative stands the ForFreight platform, a digital ecosystem that connects diverse logistics actors and systems to optimize multimodal freight operations. It addresses the digitalization gap and fragmentation that often hinder collaboration across supply chains, offering an interoperable environment where data from different sources can be combined to solve real-world logistics challenges. Through its comprehensive library of digital solvers and innovative workflow engine, the ForFreight platform transforms raw data into actionable insights, supporting smarter decisions, greener operations, and stronger collaboration. The platform comprises a set of functions and capabilities that enable the efficient digital configuration, execution, and assessment of multimodal logistics operations, acting as a community layer that integrates existing logistics systems, digital services, and stakeholders into a common ground for efficient, data-driven, and sustainable intermodal transport across Europe. Users are first greeted by the ForFreight login page. Enter your email and password as you would on any standard sign-in screen. Behind the scenes, the platform's authentication and authorization services verify your identity and apply role-based access control. Once signed in, you'll see only the pages and features enabled for your role, with certain advanced tools available solely to developer accounts. After signing in, you land on the ForFreight homepage, your control center for day-to-day work. Scroll to explore the platform's overall concept and project objectives for quick context. At the top right, the profile menu provides quick access to the e-learning platform and log out. On the left, the main navigation groups features into Home, the current page, Request history, Marketplace of solvers and solving processes, Intermodal interface wizard, Workflow engine, Onboarding of solvers and solving processes. Going forward, we will visit and demonstrate each menu option and feature in detail, showcasing their purpose, functionality, and how they support your work within the ForFreight platform.
The Solver Marketplace page presents the user with the list of solvers available to them. For each solver, there is some information present in their card, but more information on each particular solver can be visualized by clicking the Read More button. This shows additional information split in 6 different tabs where, apart from the description, the real-world problems the solver aims to solve are presented, what category the solver can be put into, what solving processes it is a part of, if any, what endpoints are available, and its intermodal interfaces. The user can also run any of the solvers available in the marketplace in order to get their output. For example, we can search for ETA prediction. By clicking the solver named ETA prediction trains run button, the user is redirected to a different page, where, after the desired endpoint is selected, the inputs required to run the solver will be in display. This solver predicts the arrival time of a train departing from Port of Galati to the selected destination. The submission form requires the desired destination and the departure time. These parameters need to be filled with appropriate values. In this example, the destination will be Bucharest and the departure time is the XTH of Y at A hours and B minutes. The values can now be submitted and the results of the solver are displayed.
Going back to the solver marketplace, now searching for Container Port Dwell Time Predictor, which predicts the total stay duration of the cargo at Port of Valencia, and clicking the Run button on this solver. The user is again presented with a form with parameters required by the solver. This time, a container number and a bill of lading number. After filling in these fields with valid input and submitting the values, the results for the given inputs are now shown. This particular solver outputs its results in a TIC 4.0 format, but the duration can be retrieved from the timestamp and value here. The next solver further demonstrates the different output formats available in the platform. Search for Real-Time Tracker. The solver provides the best route from Port of Piraeus to Athens International Airport. This solver is meant to indicate the best route from and to static points at the time the request is made. Therefore, it does not require any form to be filled and can be run right away. The result of running this particular solver actually displays a map with the best route, as the output is a set of coordinates which are quite hard to understand otherwise.
The Solving Process Marketplace is presented in a similar fashion to the Solver Marketplace. where a list of available solving processes, with the option to get more information or run the solving processes are presented. By clicking the Read More button, additional information can be seen regarding the selected solving process. This information includes its overview, the intermodal interfaces it affects, which solvers are included in its execution, along with any legacy system it may use, and finally what real-world problems it aims to solve. By clicking the Run button on a solving process, click Run. The solving process's inputs are now displayed. For solving process GR_SP2, the inputs required are the time the freight leaves the port, any unexpected delay, the location of the destination, and the maximum allowed time it needs to arrive there, namely freight arrival, duration, location, and user end date time, respectively. Once this form has been filled with the required parameters, the solving process will run through the various solvers included in it and provide the user with a final output, which will be the list of the feasible flights that suffice the constraints. Indicatively, the following values can be passed. Freight arrival, October 8, 2025, 10:36. Duration 3. Location, Amsterdam. User end date time, October 18, 2025, 10:36. The user is able to see all the intermediate steps till its arrival at the airport along with the timestamps and the list of the feasible flights that can be assigned. The steps and timestamps are the output of the solvers the solving process consists of. The request history page allows users to review the various results obtained from solvers and solving processes during previous runs. The data table can be filtered by date, time, and service. Reviewing the output of each request also allows users to download the output of the selected request. Apart from this page also contains the Analytics tab. This page allows for the visualization of graphical representations of previous results obtained from solvers or solving processes. These results are generated dynamically for every integrated solver or solving process, including any added externally via the onboarding processes the platform offers. The Intermodal Interface Wizard provides a wizard-like guided path to run solving processes. Start by selecting the desired intermodal interface, for example road to air. Then choose the real-world multimodal transport problem for that interface. Next, pick the solving process suggested for your selection. The wizard then presents a focused input page with only the parameters required for that process. Complete the inputs and click Submit. Again, the solving process will run through the various solvers included in it and provide the user with a final output. By narrowing choices step by step, the wizard removes guesswork and provides a guided, more user-friendly experience.